So we're looking at problem 28 in section 6.4, and this involves absolute value inequalities. And just like with inequality, you need to isolate the absolute value sign or the absolute value expression by itself. So to do that, I'm going to add 3 to both sides of the inequality. And then I still have an expression that has the absolute value sign in it. And now it's less than 2. So now from this expression, or inequality, I can rewrite 2 inequalities without the absolute value sign. The first inequality is going to be written just the way you see it here, except without absolute value. So we're going to have x plus 4 is less than 2. And then the second inequality is going to be the same expressions that you have here, except that you're going to have a greater than sign, and it's going to be negative 2. So we have x plus 4 greater than negative 2. And then we have to figure out, is this an or inequality or an and inequality? Are we going to be looking at the intersection of the 2 inequalities, or are we going to be bringing the union together? And the best way to figure that out is by looking at my sign here. And my sign here is a less than. Notice how I'm emphasizing the than. So that tells me what kind of inequality it is. It's going to be an and inequality. So that means I'm going to be looking at the intersection of the 2 inequalities. Intersection is going to be my solution. So I'm going to go ahead and solve these 2 inequalities now. I'm going to subtract 4 from both sides. And I'm left over with x less than negative 2. The second inequality, again, I'm going to subtract 4 from both sides. And I'm left over with x is greater than negative 6. So we're looking at the intersection. I'm going to go ahead and draw my graph, my number line, with negative 2 and negative 6 on it. And then I'm going to draw the inequalities for each of these. So x is less than negative 2. So that's an open bracket, and I'm going to be going to the left. And then my x is greater than negative 6. I'm going to start at negative 6, not including it, and going to the right. And I'm looking for the intersection of the 2 graphs, and that's going to be between negative 6 and negative 2, not including negative 6 or negative 2. And it says to graph the solution, so let me go ahead and graph the solution set. It's going to be between negative 6 and negative 2, and negative 6 is in one interval, but it's not in the other. It has to be in both intervals to qualify. So there's the graph of my inequality, and then my interval notation is going to be negative 6 to negative 2, not including either end. The next inequality I'm going to do is number 52 in the same section, 6.4, and here we have the absolute value of 2/5 x plus 4 greater than or equal to 3. So in this particular problem, my absolute value is already by itself on one side of the inequality. All I need to do is rewrite it now without the absolute value signs. So it becomes 2/5 x plus 4 greater than or equal to 3. So the first inequality is always the same as one that you started off with without the absolute value signs. And then the second inequality is going to be 2/5 x plus 4. I'm going to switch my inequality sign, and I'm going to switch my 3 to a negative 3. Then I'm going to look at the inequality sign that I started off with, and that inequality is a greater than or equal to. So I'm going to write this as a greater than or equal to. So this tells me that I have an or inequality, which means I'm going to be looking at the union of 2 inequalities. So going ahead and solving, I'm going to subtract 4 from both sides. I end up with 2/5 x greater than or equal to negative 1. And then I'm going to multiply by the reciprocal of 2/5, which happens to be 5/2. Make sure that I do that both sides of my inequality. And when I do that, I end up with x is greater than or equal to negative 5/2. The second inequality, I'm going to subtract 4. I end up with 2/5 x is less than or equal to negative 7. I'm going to multiply once again by my reciprocal, which is 5/2, both sides. And on the left, I end up with x. On the right, I'm going to end up with negative 35/2. It may be helpful for you to rewrite these as as mixed numbers. So this ends up being negative 2 1/2. So when we go to graph, we have a better idea of where these are located on the graph. And then this equals negative 17 1/2. So going ahead and graphing these on the number line, here's 0, here's negative 2 1/2, here's negative 17 1/2. And graphing each one of my inequalities, so x has to be greater than or equal to, so I'm going to be going to the right, and since it can be equal to that, it's going to be a square bracket. And then x is less than or equal to negative 17/2, that's going to be going off to the left. The union of these two inequalities is either this interval or this interval. So this is the solution set that I've graphed. Writing in interval notation, I'm going to start off on the left. I'm going to be at negative infinity to negative 35/2, or I use my little union symbol, and don't forget that's included, inclusive negative 5/2 to infinity. The last problem I'm going to do in this section is number 60. Again, we're given an inequality with an absolute value. The absolute value is already by itself. So I'm going to write two inequalities without absolute value. The first inequality is going to be the same as what you see above. And the second inequality is going to be the same on the left, but on the right, I'm going to make it a less than or equal to sign, and it's going to be a negative 1/6. This inequality is a greater inequality. That means we're going to be looking at the union of the two sets. So what's in one set or the other set or both. First thing I notice is that I have fractions in these inequalities. I want to get rid of the fractions. I'm going to look for the LCD for 3 and 6, and my LCD is 6. So I'm going to multiply both sides of my inequality by 6. When I do that, I end up with 6/1 times 2x minus 5/3 greater than or equal to 6/1 times 1/6. I'm going to do the same thing over here. 6/1 times 2x minus 5 all over 3 less than or equal to 6/1 times negative 1/6. The reason that we multiply by our LCD is so that we have the removal of our denominators. So you should be able to cancel out like factors, remove those denominators, and then simplify. So what are we left over with over here? We have 2 times this quantity, 2x minus 5. The 3 and the 6 we're able to cancel out. So I end up with 2 times the quantity, 2x minus 5, greater than or equal to, and this all canceled to become 1. Over here I have the same thing, 2 times the quantity 2x minus 5 less than or equal to negative 1. And I'm going to put in my or in here so I remember what it is I'm trying to do. Using the distributive property, I end up with 4x minus 10 is greater than or equal to 1. I'm going to add 10 to both sides. I end up with 4x greater than or equal to negative 11. Dividing both sides by 4. Now I'm dividing by a positive, so that's okay. My inequality is going to stay the same. X is going to be greater than or equal to negative 11/4. And you may want to rewrite this as negative 2 3/4, so you know where to graph it on your number line. Same thing over here, going to use the distributive property. Then I'm going to add 10 to both sides. I end up with 4x is less than or equal to 9. Divide by 4. X is less than or equal to 9/4. And again, you may want to rewrite this as 2 1/4, just so you have an idea of where the number it is on the number line. What I've just noticed is that on my last inequality here, I added 10 and I ended up with negative 11. It should have been a positive 11, and then carrying through. Now I'm going to go ahead and graph the inequalities. Here is 0. Here is positive 2 and 1/4, and here is going to be positive 2 and 3/4. So now I'm going to be greater than or equal to 2 and 3/4. So that means I'm going to be going to the right, and it's inclusive. And then I have this one I'm going to graph, which is x is less than or equal to 2 and 1/4. So now I'm going to be going to the left. That's what my graph is going to look like, the solution set. And then if I were to write it in interval notation, I'm going to be going from negative infinity to 2 and 1/4, which is 9/4. Oops, inclusive. Or inclusive 11/4 to infinity.